Hello, hello, hello. Welcome to DASA Connect 2024. This session is titled Infrastructure as Code for the Non-Developer. I'd like to welcome you. I guess good morning, good afternoon, and good evening. For me, it's the morning here in sunny Chicago, Illinois. So I would like to start this presentation uh, talking a little bit about myself and my name is Richard Taylor. I am the technical team lead for consulting services at Ahead, and I am based out of Las Vegas. I just happen to be in Chicago for now, but I have years of experience with DevOps and IT in general. I'm a former Microsoft employee, actually twice. I've worked for both the BPOS architecture team, which eventually became Office 365, and the OpsCon team as well, which is a Premier and Microsoft Consulting Services. I've written a few books. Also, they are a little bit dated, but I do have authorship in several books. And this has been very dear to me. This concept of DevOps, as the title says, this is for the non-developer. And the reason why I wanted to state that is because that is where I'm going to actually focus on the way that we think, because we, as IT admins or sysadmins or operations people, think a little bit differently than, say, developers. What you can see on the screen is my contact information. I'd love to connect. So please go ahead, take a screenshot or shoot me an email. Would love to chat with you. So let's jump right into it. The agenda for this particular session is DevOps for the non-developer. So in the spirit of full transparency, I'm going to be presenting from the perspective of someone who is a sysadmin or operations or what we used to call IT pros. Okay, so from that perspective, I want to start off with the understanding of what we will be discussing and level set by talking about what IAC, infrastructure as code, and CAC, configuration as code, mean. And then I'll go into discuss the core principles of IAC and CAC and how they apply from the perspective of a sysadmin. Then I'll move on to breaking down what those principles mean and where they're employed and the tools that we can use to apply those principles. Then I'll take the information that I have given to you and I'll do a demo and I'll show those principles. Again, they'll be from our perspective. So on the screen, you can see a couple of definitions that you could probably get from the internet, devops.org and so forth. What I'd like to point out here is the nuance. Okay, there's a whole bunch of levels of or degrees of nuance that we place on these definitions, but in practice, we most likely will combine the two between IAC and CAC. They are typically combined. And I'll kind of return to those definitions here a little bit later. So let's start talking about IAC or infrastructure as code. So those principles and tasks that we as sysadmins use to develop a proficiency in these are not remarkably different than what a typical sysadmin would use, but we would speak it in, let's say, a different dialect. Okay, one concept that helps with that understanding is the relationship of source control and continuous integration and continuous deployment. We call that CI/CD in a lot of words. We also start with the concepts of source control, and then from a CI/CD process, making this all work together are things that developers have typically used over the years, which is something that sysadmins have not done. So I want to go into source control and then from the practice of tracking and managing changes to that code, because that's also something typically that sysadmins do not do. So we do keep scripts and we typically employ those or even write those, but we don't typically use version control. We typically don't use a type of repo and CI/CD process in doing those things. And I'll kind of demonstrate that a little bit later. Now, source control will protect our code from catastrophe, casual degradation, human error, unintended circumstances. And what I mean by that is, as sysadmins, we'll write uh, code in PowerShell or Bash or some other language. And what do? We'll put it on a file server, or we'll keep it on a desktop. And then if we work in a team, where is that code kept? Someone will update it on that file server, and we may use the one that's on our desktop. And so we're not always using the same versions. And when we do change those, we don't know who made those changes. So we don't even have a history of that. But developers have learned that by keeping track of where the code lives and what version is current, they have better control over what to deploy and when to deploy it. In software development, they work on a project, typically in the same code base, which is not the experience of a sysadmin. The scripts that we use were typically written by one person, right? We don't typically work together as a team, sysadmins. We use the code as a team, but we don't typically write them as a team. So if we make updates, typically we don't know who did that. Using source control will force the concept of there's one source of truth. Okay, using version control, that will encourage collaboration and also enables automation. So I recommend that as sysadmins, get familiar with Git, get familiar with GitHub, get familiar with Azure DevOps for repos, so that we have a place to store our code and to comment and to collaborate. So we update, for example, our infrastructure, right? Some of us may still have a large on-premises environment. And so, we're used to getting bare metal and putting them in the racks and wiring them up and installing operating systems and applications and then doing that all manually. So we may even have scripts that do this for us, but we don't really use IAC in order to do this. Now, as we are starting to move to the cloud, we do these migrations and we do what we say is a lift and shift, but it's really just a lift. We're not really shifting. And so we have all these scripts that we create, we update to configure this infrastructure. But some of those need to be updated every so often to reflect the changes in the configuration. Remember, I talked about how IAC and CAC, that the nuances are levels of degrees. And so those scripts, may be well documented, but not all of them are. And then when the changes happen, the previous versions of what they were have lost. Now, how many times as a sysadmin have we used the script and it doesn't work? And we're like, ooh, where was the last version that worked? We need to act more like those developers. We need to use the same tools, use the same practices as developers do so that we can become more agile. When we don't do this, this leads to what we call configuration drift. I'll talk a little bit about that later. But for years, we've been doing these repetitive tasks, let's say using PowerShell, and we repeat these things over and over again, but we don't really share this information. So when we start to think like developers and write our code as a group and collaborate, that relationship gets a lot better. Okay, so those are the core principles: IAC, CAC, source control. Now let's talk a little bit about the approaches to implementing that. So there's two basic, I guess, approaches, right? It's called imperative and declarative. Okay, if we're using scripts, we typically are talking about imperative, meaning that it is procedural. Okay, so let's say I write some code in PowerShell. Okay, the code in PowerShell is carried out step by step. In a lot of cases, those scripts that we write have to be carried out in a particular order, so we write it that way. As the system takes its course through the script, it creates, it changes, it deletes, or sets objects, and eventually gets to a final state. Now, the other approach is using the declarative approach, which is functional. Okay, as that manifest file then gets deployed, what happens is the final state is declared on what it will look like. And then we let the system determine the order. Okay, manifest files are typically things that are written up in a markup language like XML or YAML. So creating those markup files or markup language files or manifest files is where IAC becomes a thing of beauty. So how do we create those files? All right, sometimes we use code editors. Sometimes we use Notepad++ or something like that. In the DevOps world, okay, those manifest files are typically created using the tools which I'm about to explain. These are the tools typically that we use to create these manifest files. And you'll notice that in this table, in the last column, you can see the language that the manifest file is written in. So you'll notice that in each of these tools, in each of the rows, right, they take a declarative approach. Some of them have the ability to take, either a procedural or a declarative approach because they're used to provision a system while others are used to configure a system. Remember, again, IAC versus CAC. Some of the tools are both. Some of them are only IAC and some are CAC. Puppet, the very first tool that I list in this table, operates in a client server model, and it has a master and an agent. The master is responsible for compiling the code and creating catalogs, and the agent, which sits on the machine, is managed by that Puppet master. The next one is called Chef. That's an infrastructure automation tool that is used for deploying, configuring, and managing. So this is an example of a dual IAC and CAC tool. So Chef is kind of funny. It's a tool that we use, and it has things called Knife, right? And we have recipes that create these manifest files. Okay, Ansible is an open source platform. It automates provisioning and configuration management, and it has application deployments. Unlike Puppet and Chef, Ansible does not use or employ agents. So you don't have to install any software on any managed services. You just have to configure the Ansible control. Salt Stack or Salt is Python based. It is a configuration management tool and it remotely executes applications. Terraform is an open source tool that allows you to provision tools. So this is more of an IAC tool. I have used it to do a CAC, but typically what happens is in Terraform, in the code, which is HCL or HashiCorp language, you can then remotely call, let's say, an Ansible, which was configuration management. So I can kind of combine these tools together to get the full IAC CAC stack employed. The reason why I want to use these tools is to prevent what I called before the drift. Okay, sometimes they call that the snowflake effect. What that means is let's say that I provision a bunch of resources, servers, NICs, whatever. So I have a whole bunch of servers that I have deployed using whatever tool or manually. What typically happens is as the servers or the resources age, the configuration of those things changes. And so we start getting what we call configuration drift. And then you'll get where, oh, that server isn't configured the same as this, and that's why it behaves differently. And we start having problems when we troubleshoot. So when that happens, we have to employ things such as DSC or desired state configuration that will prevent configuration drift. In this slide, we see how Puppet Ansible can be used together for configuration management. So Puppet has a manifest file that ensures that the system is declared in a certain state and that it doesn't change. So if somebody makes a change, Puppet will change it back to its original, like DSC. Ansible is configured to run a playbook that configures the cloud environment according to that manifest file. Now, these manifest files are where IAC happens. For sysadmins, this is where we want to protect our collateral, if you will. Okay, where do we store these manifest files? How do we update these manifest files? How do we collaborate in them? Okay, so I'll talk a little bit about that in a bit, but I wanted to move to why we do this. Okay, DevOps is a collaborative relationship, typically between sysadmins, operations people, and developers. Okay, the collaborative nature of DevOps suggests that operations and developers are working hand in hand. Okay, in reality, it's a little bit more than that, but for the sake of this particular talk, the collaborative nature between developers and operations is what we call DevOps. As in all relationships, the key to being successful is communication, commonality. To be successful, we need to be collaborative, and that's where we use these principles that I'm talking about. One of the ways that we as sysadmins can increase our understanding is to take it upon ourselves to adopt the practices that developers have been using for years. Then that way our goals become the same. All right, now going back to manifest files, how do we manage them and use them like devs do? The principles of IAC is how we accomplish it. We use pipelines by doing it. The purpose of using the pipelines is to enable us as sysadmins to have a place for our scripts and manifest files, and using pipelines to enable and automate the flow of changes into production. So there's 4 basic steps. First, we push the code to our version control repository. Second step is it creates and configures our build and release pipelines. The third step is it creates an artifact that is used for the rest of the pipeline. The fourth, changes are updated. We build the resource, we test it, we package it, and then we deploy it. And then we repeat that over and over. That's how pipelines work. And I will show this to you in our demo. Okay, pipeline has some basic elements, right, that allow us to do those 4 steps that I was talking about. Okay, in the demo, I'll show you each of those in a little bit more detail. Okay, now for the part that you've been waiting for. Here is the demonstration. So what I'm going to do is I'm going to use an IAC tool to deploy the infrastructure to a cloud environment. In this particular case, I'm going to be deploying it to Azure, and I'm going to be using Terraform to do it, and Azure DevOps. So one second while I change to, oh, where did we go? Here we are. I'm going to share my screen. Okay. And let's make sure that I am sharing the correct screen. One second. Okay. So here you can see I have an Azure environment, and you can see that I have a number of different resource groups. To create some resource groups and some resources that do not exist here, as you can see. I'm going to use code that I keep in a repo, and I'm going to share that in this tab. All right. Oh, wow. You know what? I need to share my screen instead of tabs. One second. There we go. That way, when I go back and forth, you'll be able to see it. Okay, so here's my repo. I have some manifest files that you can see. So here's my Terraform code that I will be running, and it will be building this infrastructure. And then I have some manifest files, which are the configuration of that code. So the first thing I'm going to do is kind of explain what is going on. So as you can see in my Terraform code, I'm going to build some resource groups. I'm going to build some Linux machines. I'm going to build a virtual machine, Windows, and some VNets, some subnets, and so forth. Okay, now in this code, I'm going to build 3 resource groups, and I'm going to build X number of subnets, and I'm going to build 2 VNets. So how do I do that? Remember we talked about pipelines. So here's the pipeline that I've got. I have a number of different pipelines. I have one, it's called DASA Demo CI Build. So let's run it. I'm going to run this pipeline. Now you can see in this pipeline, I have already built the code. So it's taking all of the code, it's compiling all the code. Actually, it's interpreting since it's HCL. It has automatically built a machine that will run this code for me. So it checked all the code out. It's installing Terraform on a box, initializing it, and it will go and build. So it will build 3 demo resource groups. As soon as they get built, let me refresh. I'll keep refreshing them. You'll see them as they come up. It's still building. As you can see, creating. There we go. So you can see I have 3 new resource groups, RG1, RG2, RG3. So you're thinking, okay, Rick, so what's the big deal, right? You just use Terraform code, you ran it automatically, and you've built some resources. Okay, so what does this have to do DevOps? So let's say now that I've built this and we've been working together um, on in those VMs, because each one of these resource groups will have virtual machines in them and network security groups and so forth. Well, okay, but now let's say that there has to be a change made. Okay, so I'll let it continue to finish it, and I'll show you exactly where this comes in. Let's see where we're at. Okay, we got a Linux box, 2 Linux boxes, and that resource group. And we got 2 Windows boxes in that resource group. Excellent. Let's go back here. And what do we have in RG3? Actually, there's nothing in RG3. Okay, well, you know what? Why even have a resource group that's empty? So what do I do? Well, because I have Terraform, there is a file called a state file, which keeps track of the infrastructure in my cloud. So if there's ever a change made, it knows what I've got. So let's say, all right, you know what? There's no need for me to have an empty resource group. So why don't I just delete it? Rather than uh, go right here and maybe someone fat finger it and accidentally delete the wrong resource group, they could simply go to my manifest file. Let's go here to the repo. We'll go here into Terraform. And here's my manifest file for the resource group list. So we saw that the DASA demo RG3 was empty. Well, why don't we get rid of that? Okay, so this is where we and the developers get together and we can say, you know what? We built this thing. Here is, the whole history of what has happened with this file. We can compare what the changes were to those files. And this thing called blame tells me who the person was and the date that they did this change on. So now, if we want to get rid of it, all we simply have to do is click edit, and let's remove this. And then we click commit. We put a comment in here, delete unused resource group. So now they know. So we'll click commit, and it will kick off a build automatically. You can see there's the build. Delete unused resource group. We come here, we see RG1, RG2, RG3. Let's refresh. Let's see where we're at. It goes in. It is now applying the configuration change. It says 1 will be destroyed. It knows exactly which, right there you can see, demo RG3. And We'll refresh. I wouldn't have thought it would have taken that long just to get rid of one. We'll let that go ahead. It shouldn't take that much longer. I'll let that go. I'll go back to the presentation. I'll share my screen again. I'll show you that after it gets done. Okay. In the demonstration, I showed how to deploy those resources. If we modularize it in that repo that I showed, work much easier, much better. So, in conclusion, infrastructure as code is a language that both devs and operations or system admins should be using in order collaboration less dysfunctional. All right, so I'm going to open this up to questions, and thank you so much for your time. I love that comment. It did not pass cab. That is thank you, Jan. That is exactly right. I'll go back and show you that my code did work, because there's nothing worse than I hate saying, did his code work? Yes, I know. I promise you it worked. RG3, and let's refresh. Oh, gone. Ding, ding, ding. And then if we go to here, we can see that it finished successfully. Okay, excellent. So Niels, thank you. Thank you so much. Okay, well, if there are no questions, then I will finish the session here. I hope that you enjoy the rest of the conference. Please, take the time to connect to one another, because we are a community. So thank you again for your time, and we'll be talking to you soon.